Hello friends, welcome to our channel where we are presenting lessons in mathematics. Like the case has been, we always emphasize the importance of you subscribing to this channel. Okay, so this channel is meant for people doing ECCET exams as well as those that could still find these things very useful. We are trying to present mathematics in a manner that is very user-friendly. Alright? We try by all means to present these lessons so that we put you in a position to be able to sit for these exams with the maximum confidence. Okay, so in this presentation, what do you want to do? Let me mention first that this is lesson number 10. Our interest is to see how we can get the area under a graph. Alright? The area under the graph. Now, I've put some points here. Okay, that can help you. We are saying the area bounded by the curve. Suppose we have a curve here, which is y is equal to f of x. That is supposing that that is our curve. Okay. Then you have the x-axis like this one. Alright? You have the x-axis. Alright? Now we are saying the area will be given by A is equal to the integral from A to B of y with respect to x. Alright? Area is equal to the integral of y with respect to x, where the limits run from A to B, that is A to B. They are lying on the x-axis. So we want to compute this area. Okay? So we are saying if this is our interest, how do we get this area? We are saying to get this area, you must integrate this. Alright? So your limit will be from A to B. So if this is 2 and this is 4, it means here we are going to say area is equal to the integral of 2 to 4 of what? Y with respect to x. How to get that? In this case, by y we mean the function. So maybe you might have y is equal to 2x squared plus 4. Okay, for argument's sake. So it means your area shall be the integral from 2 to 4, alright, of 2x squared plus 4 with respect to what? X. That's what we are saying. Alright? So now, what I'm going to do is, I'm going to put up some examples so that I am able to demonstrate to you as to how we can get the required area. Alright? So if you have been wondering as to how we can tackle this aspect, I'm here to simplify things for you. I'm here to make your life easy. I hope and trust that my presentation will make you relax. Alright? My presentation will make you be able to tackle this part without much challenges. Okay? Okay, so we are saying the area bounded by the curve, okay, will be defined by this. Is given by, we said earlier on, we said A is equal to A to B of y with respect to x. Take note in this case, what we mean is that x is A and the other value of x is B. Take note. Okay, that's what we mean here. The first value of x is A, the other one is B. Okay? So like I said, let me put up an example so that I show you what you are supposed to do. Okay? Alright, let me try to erase. Okay, so these are our examples that I've put up. We are saying the first one, find the area bounded by the curve. The curve y is equal to x squared plus 1. Alright? The x-axis and line between x is equal to 0 and x is equal to 2. Okay, so I think for us to be able to do this, we can try to come up with a sketch. Okay? So that we don't have challenges. So we can try to come up with a sketch. So I can erase the top part. We try to do a sketch. Okay, so we might have something like this one as our x or y plane. Okay, so this is our x-axis and this is our y-axis. All right. So we have a curve which is y is equal to x squared plus 1. We have the x-axis as well as I think the values of x are from 0 to 2. Okay, so we can just try to sketch this one. Okay, then we can say we have something like this. Alright? So from 0 to 2, so we might have our 2 here. Okay, can we put those dotted lines? So this could be y is equal to x squared plus c1. Okay? So the area we want to get now is take note, this is our 2. Possibly this is our 1 because that is where our y-intercept is. So this is the area we want to get. Okay. So we are saying, how do we get this area? Okay? So we are saying, from the definition, we say area is the integral from a to b of y with respect to what? X. Okay? So we are saying our area is going to be the integral. What is our a? It's the lower limit. The lower limit is a 0. So we have 0 to 2 of y. What is y? Y is x squared b plus c 1. This one with respect to what? X. So this is what we are going to integrate. I hope I'll be able to copy this part so that I can erase it. Okay. All right. Okay, so we are going to say, I'm continuing from here because of the space. So say our area is equal to, we integrate this. So this is the same as x to the power 0. Okay. So this is the same as 0 to the power 2, 0 to 2, x squared plus x to the power 0 with respect to what? X. So our area shall be x to the power 3 divided by 3. Because when you add the 1, it will be 3. Plus x to the power 1. Alright? Or just x. So we are integrating from x is 0 to x is equal to what? 2. So our area shall be equal to, so we do the substitution. Okay? So we're going to say, here where there is x, we put 2 first. Even there we put 2. So we have got 2 to the power 3 divided by 3 plus, again here we put 2. Alright? Minus, here where there is x we put 0. 0 to the power 3 divided by 3 plus, this minus is coming from the theorem, 0. Okay? But now, when you look at this is a 0, 0 to the power 3 is a 0, 3 into 0, so everything here will be a 0. So what is meant of this part? Alright, so area shall be equal to, this is what? 8. 2 to the power 3 is 8. So we have got 8 divided by 3 plus 2 over 1. So if you want, we can get the lowest common denominator, which is a what? A 3 here. Alright? So 3 into 3 is 1. By that, we have got 8 plus 1 into 3 is 3. By 2 is 6. Okay, this is what we have. Okay, so we have that value there. So I can erase the top part. So we have our area that is equal to 8 plus 6, we have 14. So we have got 1, 4 divided by 3. Alright, we can divide this because it's an improper fraction. So we are going to say 3 into 14, we have got 4. Alright, remainder 2 divided by 3 units. Alright, square units, you put like that, or you can write in weights, say square units. So that's the area. Now, supposing that the area was negative, okay, what that would have implied was that, or would have been, a negative has an implication of like this part here. So the implication of a negative is that the region that you are dealing with is below the graph, below the x-axis. So for this one, if we were to calculate this, you will get a negative value because it is below the x-axis. So if we had a negative here, the implication would have been the area that we are dealing with is below the x-axis. In that case, we just discard the negative, just get rid of the negative and maintain the positive value. You don't need to maintain the negative. The negative is just telling you that the region that we are dealing with is below the x-axis. Okay, I hope that is clear. So in this case, our area is 4 and 4 over 2 over 3. Of course, square units here. I hope I've tried to explain these things. So let's look at the other question. Okay, so let me erase this part. So we are saying let's evaluate the area enclosed by the curve y is equal to x to the power 3, the x-axis, and the lines x is negative 2 to x is equal to 2. So we are saying by definition we are supposed to have this a to b with respect to x. What does this mean? Simply means this is the region that we want to find from here to there. So what that means is that we are supposed to say we integrate from negative 2 to 2. You have x to the power 3 with respect to x. Now, you must be careful with this. Alright? You really have to be careful because if this region and this region are the same, then you get a 0. Because this will give you a negative and this one will give you a negative. So, what do you do? For such, you split. Alright? You split. So, you need to have from negative 2, maybe to 0, then 0 to 2. Get them separately. I hope I'm making myself clear. What I'm saying is that when you look at this area and this area, it's like they're equal in size. Now, because this one is below the x-axis, you are likely to get a negative here, and this one is the positive. So maybe you might get there as negative 3. The other one may be 3. So when you compute this, you get a 0. So you can't have an area which is 0. Hence, we really have to be careful. So we can try to segment. We can say, okay, let me try to get this area and get this area. Okay? Let me see what I'll get at the end of the day. Okay? So what we are saying is that for this one, we can say this is equal to the area of, let me write that nicely. The area of this part. So when you are dealing with these two, this is like your lower limit because you're starting from here to what? To 2. So from negative 2, you go to negative 1, 0, and so our lower limit will be negative 2. So negative 2 to what? 0. Alright? Of x3, x to the power 3 dx plus. Alright? So you now pick it from 0 to 2. So again, integrate the same function. X to the power 3, but now from 0 to positive 2 with respect to x. Okay? So let's see what we are going to get. So our area shall be the first one. Okay, so we can get them separately. So I'll start with this, then get that. Alright? So we are going to say x to the power 4. The power 4 divided by what? 4. Okay? Alright? Now, this, we are integrating from negative 2 to 0. Okay, so what I'm trying to do here is to get this area first. So let me segment. Let me try to segment, alright? That we see what we're going to do. So, what does this mean again? We can say, since here, we have x over 4, which is like 1 over 4, alright? There's x to the power 4, negative 2 to what? 0. Okay? So your area there shall be 1 over 4. Alright? 0 to the power 4 minus, I'm using now these limits, negative 2 to the power 4. Alright, so area shall be 1 over 4, open bracket, 0 minus 16. Okay? 0 minus 16. What we get? Okay, just looking for a place. I didn't want to erase this. Okay, let's take note. I'll write it here. Okay, so here, alright, so let me just utilize this space. It's fine. We'll be able to do it. So here we have area that is equal to negative 16. Sorry, this is 16 and 14. Okay, so we have negative 16 divided by what? 4. And here we get negative 4, right? Square units. Okay, this is our area. Alright? What does that mean? This is what I was talking about. So this is negative. Just trying to tell you that the area that we are dealing with here is below the x-axis. Okay? So now we can get the area of okay. We can get the area of this, alright, region. So we are saying, for that one we say area is equal to, we are integrating, because we are dealing with this part, I mean. So we are integrating from 0 now to 2. With respect to what? X. So our area shall be equal to, it will be the same value here. Alright? X to the power 4 divided by 4. But our x is from x is equal to 0 and x is equal to 2 here. Okay? What does this mean? It means therefore that we say area is 1 over 4. Open the bracket. So this one is x to the power 4, you put 2. So there will be 2 to the power 4 minus 0 to the power 4. Okay. So our area is equal to 1 over 4 multiplied by 2 to the power 4 is 16 minus, if you want here, you have, we can put the brackets first. You have 0. Okay, you close. But now 16 minus 0 is 16. So we can easily get rid of this and just deal with the 16 here. Alright? Just deal with the 16. What does it mean? Here you have got again the area of 4. So this is what I was saying earlier on. So if you are going to add 4 to 4, you get 0. But you're able to see the space here. You're able to see these regions. Okay. So here you ignore the negative sign. Why? Because you are acknowledging the fact that the curve here is downwards. It's below the x-axis. Meaning that our area now shall be, the actual area shall be 4 plus 4. And the answer is 16 square units. That one is our answer. That is our answer. I hope that is clear. That is our answer. That is our answer. So sometimes you have to be careful, otherwise you might just get it wrong somewhere. So segmenting it helps you to get the correct answer. So here you can copy and try to attempt these questions, especially question 3 and 4. Question 3 and 4. Alright? Question 3 and 4. Question 3 and 4. Thank you so much. I hope you have enjoyed my presentation. Please, if you have, I would encourage you to subscribe to our channel and share it with your friends. Thanks so much.